It's just started. We got some more people joining in. Okay, so welcome to our ASHRAE Midlands event. It's going to be a very interesting one about the indoor air quality. Darren in a second will introduce the speakers. I would like to thank our sponsors such as Vexo, IES, and Hilson Moran, Fisria, Train, EcoSense, and Kingspan. We are very grateful to them sponsoring our chapter. And then if you want to join ASHRAE Midlands chapter, please let me know. We are looking for the committee member, so please get involved and attend our future events. We have got next month, we got an event on heat pumps, and after that it's about trend control system on air quality. So over to you, Darren.
Thank you, Maru. And we're always looking for more sponsors as well, I should add, as well as members. So just thanks everyone for attending this evening, and giving up your time. And certainly thank you to our speakers tonight, Robert Wallerton and Colin Armstrong, both from WCS. So Robert has worked in the ventilation hygiene sector since 2003. Offering a technical role with specifications and solutions to clients for managing ventilation hygiene within buildings. And Robert's work is heavily involved in working best practice to best practice standards. Colin Armstrong joins us as well from WCS, as I say, and Colin has a vast experience in air hygiene sector, both operationally and in surveying of monitoring and ventilation systems, advising remedial action. And Colin spends much of his time providing technical lectures on best practice for ventilation system hygiene. I hope I didn't steal your thunder too much there, chaps. I just wanted to do a bit of an abbreviated bio, really, that you sent over. So thanks for this evening. Thanks for putting this together. And without further ado, we shall hand over to you.
Thank you very much, Darren. And good evening, ladies and gentlemen. Thanks for your time. So I'll just sort of kick off as Darren said there. My role has been for the last 18 years technical experience in the ventilation hygiene industry. I think you can sort of see the resume there. We work from anything with an office building with a supply and extract fan, right up to buildings with 30, 40 air handling units, all of different types. So we come across a lot of different types of system that we work with in the air hygiene industry, also covering a multitude of different elements such as hospitals, universities, that sort of thing. I think one thing I wanted to reflect on since I started in the industry 17, 18 years ago, there was really only 3 or 4 main air hygiene companies within the sector at that point in time. I think it's fair to say now we're sort of looking at in the region of probably 8 to 10, it's difficult to say, but around 8 very big companies carrying out air hygiene compliance work, and also a lot of smaller companies setting up doing air hygiene related work, with a lot of facilities management companies also setting up arms. So it's really increased in awareness because the demand is there. And I think, as I put on the footnote there, we all have the same objective of improving and maintaining air quality within the area ventilation systems serve. So if I just go back a bit in history here, I picked up on an interesting note that Florence Nightingale, in her 1859 book, Notes on Hospitals, where she laid out the need for good sanitation, ventilation and airflow in hospitals. As, of course, in the 1800s, pandemics were the greatest cause of death. So it's interesting the fact that she laid out this at such an early stage. And And I think it's fair to say that her work during the 1900s, this model was adapted and saw a reduction in deaths due to the her advice and what she'd recommended. So for a starter, I just wanted to cover the sort of legislation and guidance and then move on to the standards and guidance within our industry. So here you can see the Workplace Health and Safety Regulations L24 2013 require, under Regulation 6, building owners and managers to ensure that enclosed workspaces are ventilated with fresh and purified air. Regulation 5 imposes a duty to clean ventilation systems as appropriate. That as appropriate is a bit grey, and ensure they are subject to a suitable system of maintenance. And then you can see there's other things which also listed, which are guiding law and regulation. It's not like your Legionella control where you have, for example, L8 and HSG 274, where it is more stipulative on what you should do. So if I just come on to the standards and guidance that we work to, really the industry started with HVCA, the Heating and Ventilation Contractors Association, which changed its name to the Building and Engineering Services Association, to which people might be a bit more familiar. They may remember the HVCA, they may not, but HVCA started in 1998 with the publication of TR17. That established a level of particular cleanliness verification for both new and existing ventilation systems, and when it should be considered appropriate to clean them. It also considered kitchen grease extract systems. We then later saw British Standard 15780 introduced in 2011. That was a standard which applies to both installation of new and existing ventilation systems. So we then went on to, and just at the bottom there, we've got HSG 202. That gives current ventilation standards and advises building managers on how to achieve effective ventilation in their workplace. It also outlines methods used to assess the effectiveness on the ventilation system and sets out legislation on what you are required to do to ensure effective ventilation. So then we move on to the second edition of TR19 2013. That incorporated elements of BS 15780. The main reason for that was it covered new ventilation systems. What happened when I started in the ventilation industry, there were a lot of buildings being built under the private finance initiative, the PFI scheme, which there were a lot of hospitals being built, schools, mainly hospitals and schools. So hospitals which may have 50 or 60, in certain instances, air handling and ventilation systems. And there was the building contractors that were putting these large constructions up at the time, were sort of coming to the ventilation hygiene industry and saying, you know, we've got a dirty ventilation system there, but there's no real standard for testing that and verifying the system. So that's where BS 15780 came in, and I'll come on to later in the presentation what that really covered in terms of pre-commission ductwork systems, because essentially you were having large hospitals, in some instances, handed over to the NHS, educational establishments with a contaminated ventilation system with builder's dust, which is notorious for getting into ductwork systems. So BS 15780 really hit that on the head and tried to stamp that out and within the industry. So I'll come on to that a bit later on, but Health and Technical Memorandum 0301, that is specifically for the NHS and medical areas of compliance. So that also is a very good document. We also refer to in the industry as good guidance. SFG 20, that's over 4,000 pages that provides schedules of legislative requirements and timings in order to cover the maintenance of ventilation systems and other things and air quality. And that covers actually 70 different equipment types. So that is also what a lot of facilities managers use, building managers in the ventilation industry, to set tasks for air quality and maintenance tasks to carry out on the ventilation and other systems. So if we talk here, I'm just going to talk a bit about design specifications. These are the specifications that consultants will be writing for new ductwork installations and perhaps even alterations to ductwork systems. Mechanical contractors will read these and we read these. So you can see here, for instance, there is a lot more emphasis being put onto ductwork access and ventilation maintenance. This is an extract from a whole new building installation ventilation system covering all the elements of construction, M&E wise, mechanical and electrical. And as you can see, it says here access panels should be installed in all ductwork systems to facilitate cleaning and inspection. So inspection of the internal ventilation systems, which of course relates back to the air quality within the served environment, built room environment. So access panel provision shall be commensurate with vacuum type cleaning for duct sizes large enough for man access and mechanical brushing for smaller ductwork. So really they're also considering the size of access doors that need to be installed, because we sometimes go to projects and we find that access doors are too small to actually either facilitate an inspection or carry out ductwork cleaning. So I was talking earlier about the contractor shall utilise a specialist cleaning contractor to validate the duct cleanliness prior to commissioning and handover to validate its compliance with BS 15780 guidelines. So that goes back to what I was referring to here, the British Standard 2011. So that is now filtered out into specifications, which is fantastic as far as we're concerned. And I'll talk about the class of, here you can see it refers to medium. I'll come on to that a bit later on. Here, they're actually, this is an extraction from another specification where they're actually saying the ductwork cleaning specialist shall attend site during the ductwork installation and advise the ductwork installer of all necessary access panels or hatches required for cleaning and hygiene inspections, both initially and during the life of the ductwork installation. So what they're saying is here, really, they're considering the building life, the building as it progresses through its life, because it may be designed to do a certain thing in terms of the specification, but as time progresses, is it being used, the whole ventilation system, to how it should be? So this is really filtering out into specifications now, and that has taken quite a bit of time to do that. So we often refer as ventilation hygiene, out of sight, out of mind. Here you can see a typical layout, and office users and building users may not fully appreciate what is above the ceiling tiles, the pop-up ceiling tiles. So this really shows a ductwork layout here and the expanse of it within an office area. Here you've actually got primary ductwork marked as pink or yellow, pink I think it is, and that's serving fan coil units. So you've got open ends here which actually serve another filtered unit here, fan coil units, which are in the office environment. And the recommendation is, in an office environment, the fresh air ventilation rate is 10 litres a second per person. So that is the advice given here. You can see you've got lots of different rooms, and you can imagine lots of different functions, numbers of people in rooms, and different air quality potentials in different rooms, different humidities and all the rest of it, temperature, carbon dioxide, depending on the number of people that are in that room at the given time. So that's why we refer to it as out of sight, out of mind, because you often see all this ductwork above ceiling tiles, and we know it's there, but do the building users? So then we come on to the types of tests we would do within a ductwork system in terms of hygiene. And when I was talking about the BS 15780, which is incorporated into TR19, that has classified, what that did was classified buildings, or classified rooms and buildings. So here you can see low classified areas, that would be storage rooms, corridors, that sort of things. Medium, offices, and this would be for the most part cover most buildings and the usage. High, we've got labs, treatment areas in hospitals, that would also be theatres, operating theatres, that sort of thing. So in accordance with those guidelines, we have here classifications. So we've got dust deposit thickness test and preferred vacuum test. The preferred vacuum test is a lab analysis and measurement of dust over a given area. So you can see here, if we've, for example, got a new ductwork system, or this is actually supply ductwork, we've got, if we were to have 60 microns for a dust deposit thickness test, anything above that would be considered it needs remedial action in terms of cleaning action. So we've got the different classifications here depending on where we are on that scale there. The building usage it gives, obviously for extract the level is higher, and also there are also advisory levels for new ductwork installations as well. So if you have a new ductwork installation and a building manager or a builder wants that system verified, you can verify that system with a preferred vacuum test depending on what classification it is. So then we come on to dust deposit thickness tests and regular inspection monitoring intervals in months. So this defines when the recommendation within the guidance TR19 gives you, in terms of the classification, when you should be inspecting various elements of your ventilation system. So that's a good, this high, medium, low was fantastic for the industry, and it really did give people some excellent guidance. So the dust deposit thickness test, what is that? Alchemeta was designed to measure the thickness of paint on cars, and this really, we go in and we carry out this is the methodology we use as detailed here, and then we do 3 test points per system, which will give you an average reading for that particular supply or extract system. And then we come on to here, this is a typical sort of test that has been carried out, and you can see we've carried out various dust deposit thickness tests here, got various readings across the system depending on Where that is, you could either carry out localized cleaning or a full system clean to rectify the contamination within that duct and ultimately improve the air quality within the served area. So additional considerations to dust deposit thickness tests and air hygiene surveys. So you should always take photographs of the visual of the system. Visual inspection should really be the primary method of a building manager or an air hygiene compliance company coming in and doing a check on the system for contamination. We then come down to fresh air intakes. When we talk about fresh air intakes, they can be a big area of contamination and can affect depending on, so for example, you can have where the fresh air intake is, you could have that on a basement level, which is next to a busy road and letting exhaust fumes into the building. You could have the fresh air intake located next to a kitchen extract system exhaust and therefore have kitchen extract exhaust fumes coming back into the fresh air intake and going within the building, spreading fumes within the building. Frost coils within air handling units, they can have a great impact on affecting the flow rates within the system if they become contaminated and blocked. Filters, I'll come onto that later on. And then various other things, checking fan belts, which should be part of the general maintenance anyway. So here we've got guidance. We wouldn't generally recommend using bacterial tests on an internal ductwork system for a verification of cleanliness, because generally they will usually fail. We've had circumstances where we've actually disinfected the ductwork prior to taking a test to actually do a blank test, and we've had those come back and fail. Generally, they should only be used if there is a case of within the building of someone actually coming down with an illness which could be from the ventilation system. And then TM26 advises in that instance, you should perhaps consider taking microbiological tests. So we generally find that they're not, the results on those can be very haphazard, if you like. They're not a good indication of cleanliness within the ductwork system. So here we come on to some of the issues we find on the internals of ventilation systems. Here you can see filters imploded and also heavily clogged with debris there. Site should have a regular filter changing regime, and also you can get filter bypass from the various points there. That is a regular thing that we find. Filters also heavily clogged with moisture. That's probably the most common thing we find with buildings, is not having a regular filter changing regime, and we often find that brand new filters are stacked up in the boxes in plant rooms and not actually being put into the air handling units, and you find filters like this. This is a clog system here on the right, bathroom extraction system or a toilet extraction system. You would generally find this to be. Here you can see microbiological growth on it. I think that's a filter section or a coil section there. And there you can see the sorts of results you can have on a fan impeller, not only include improving the air environment within the served area, but also improving the fan efficiency and the bearings on the fan by not having the system and the fan running with contamination on it. Bearings also on fans can go with contamination on the fins. It throws them out of balance. So an interesting one here, disinfection of ductwork. People often say to us, can you disinfect the system when you completed? Are you going to fog the system? Under the HTM 0301 guidance, fogging, disinfection of ductwork is not recommended. Actually introducing moisture to the ductwork can actually cause the galvanized coating on the ductwork to be affected, and also we understand that introducing moisture to the system can also cause proliferation of bacteria. So you should only disinfect ductwork if it's clean and if there's a need to do it, as in there's been a risk identified that there is a need to disinfect that system. So just to clarify, disinfection of ductwork is not recommended. So what's my personal opinion of where air hygiene is going in terms of air quality? Well, I think it could be a bit like Legionella control. Legionella control, you are required to do a risk assessment on systems. You are required to monitor systems. And the principle of Legionella control within a building, and it has been for many years, this natural forming bacteria within water systems, is to keep the water moving, keep it hot, keep it cold, and keep it clean. Legionella likes to live between two different temperatures. So, and what happens if you can't control Legionella with those elements there? Things are introduced on large water systems such as dosing, UV light, to help to also assist control the risk. So air could eventually follow this same principle where we're using indoor air quality devices, and I think Colin will come on a bit more to that, to monitor systems and room environments in the future. So that's basically where I see it going. So Colin, without further ado, I'll hand over to you.
Right, I've got it. Am I in charge of it now, Rob?
I don't know. You can. Yes, I believe you may be, Colin. I've allowed access now. So if you just want to test it, I don't know.
How do I go from page to page?
Scroll down. Yeah, I think you've got control there, Colin.
All right, okay, brilliant. Thank you very much, Rob. I'd just like to go back to something that Rob actually said, the disinfection of ductwork in the HTM, the NHS guidance, and about the non-fogging of chemicals and putting them in ductwork systems. First of all, I like the HTM compared to a lot of some of the industry documents because it's very unbiased. There's no agenda there, and it's just very, very good advice. Many years ago, I went and sat a course on the HTM, and the guy that had written the guidance was actually chairing it, and he was very open about the fact that he hated ductwork cleaners, which was very hard for myself and my colleague who was sitting there at the time on the first day, in the first hour of it, because we were the only duct cleaners in the room. And he came out with it and said that it was a good excuse for a duct cleaner to make some money putting fogging in a piece of ductwork. So just wanted to reiterate what Rob had actually put there with the fogging with chemicals, and how the guy that actually wrote the guidance was saying it really isn't needed. There's just no need for it. It's not going to achieve anything by doing that to the well-being of a patient. So I just want to touch on that. So moving on, I've been in the industry for about 13 years. I've looked at every type of system out there, I think. I like to think I give common sense knowledge. I don't try to make it too technical for people. I think it's much easier to give someone an open and honest opinion. I've worked on loads of projects all over the country, hospitals, local government, commercial buildings. It's varied what you come across. And the ultimate goal of that is to give people the best possible advice. They don't always understand, as I say. I like to just give it to them in simple terms, because I think that's the best way forward with some of the clients. So, indoor air quality. Building occupants are exposed to a variety of pollutants, and they can, this can include volatile organic compounds, and they may be emitted over periods of weeks or years from construction, furnishing products, concrete, masonry surface treatments, damp proofing. The list is endless. Roofing compounds, even air fresheners, and there's also other indoor sources, which could be cooking, cigarette smoke in the home, and even road traffic. And then you have formaldehyde, which is a volatile organic compound. It's released directly into the indoor air. Again, that can come from resins, wood-based products, furnitures, lacquers, foam, cavity wall insulation. Carbon dioxide. I think we all know that us and animals, we give it off. Plants can, but if they get enough light and initiate photosynthesis, then they can reduce the levels of carbon dioxide. Ozone. This arises from the photochemical reaction in the ambient air, and from electrical equipment such as printers, photocopiers, and it may undergo reactions with surfaces and other airborne pollutant indoors to produce new compounds and particles. Nitrogen dioxide, that comes from cars, trucks, and buses. They're probably the largest sources of the emissions, followed by power plants and heavy construction equipment and other movable engines and industrial boilers. I don't think people realise that, when you start breaking these down, that there's so many different influences on the indoor air quality. Particulate matter. It's made up of, a mixture of solid and liquid particles suspended in air. It can be carbon, organic chemicals, sulfates, nitrates, ammoniums. Again, the main sources of particulate matter are from combustion and transport. And then we can move on to biological pollutants. It can be fecal pellets from house dust mites, mold, fungal, bacterium pollen, moisture, such as can come from cooking, washing, odour. Common sources of odour are from ventilation extracts, especially from kitchens and restaurants. We see hundreds of these a year within our industry, and I have guys going out every night and coming across this. Diesel emissions, aerosols, cosmetics, plug-in air fresheners, cleaning, personal care products, and obviously cigarette smoke. Industrial pollutants, they could be, they can be generated in urban areas from waste incinerators, vehicle spray booths. There's a vehicle spray booth a quarter of a mile away from my house, and on a good day I can smell it in the wind. And from diesel powered generators. And it's also possible to get gases from soil beneath buildings containing hazardous substances. These may be of a natural origin and be released by the bedrock. But yeah, as you can see, there's so many different types of contaminants, pollutants out there that maybe people just aren't quite aware of, or just have never thought of it before. So poor indoor air quality can cause a range of health effects, ranging from headaches, nausea, asthma. As well as being detrimental to the health and comfort, poor indoor air quality can adversely affect performance at work. We all know what it's like when we're sat there and the air isn't fantastic. We start to get a bit tired and a bit lazy, I suppose, sat at our desks, and it affects that performance. And it can also affect learning in educational establishments and and in healthcare situations. The extent of the effect of particular pollutants on human health depends on its concentration and the duration of exposure. In the industrial workplace, many of the most serious risks are addressed with local exhaust ventilation, with residual risks controlled by PPE and exposure monitoring. However, in domestic and many non-domestic environments, the control of indoor air pollution may not be achieved as easily. There are workplace exposure limits, and they may apply for healthy people or working age who are exposed to a pollutant directly as part of their work. For those people not in good health, and for those younger or older than working age people, lower exposure limits are usually employed. So, but the lower limit should be applied if a person is exposed to the pollutant for significantly longer than 8 hours, or if their work actively does not directly involve the pollutant. If I come down. So, control strategies. The control strategies to reduce the concentration of the air pollutants in the indoor environment depend on the type and the location of the source and activity. Ventilation with outdoor fresh air will dilute and flush out pollutants derived from indoor sources, but they will not eliminate them completely. It's impossible at the moment. And in fact, the incoming air could also be polluted from an outdoor source that we're bringing in. It depends where the intake on a system is, or wherever your window is. There's so many factors to it. So care needs to be taken in selecting the correct mitigation strategy to give optimum indoor air quality for people's health and well-being. So what can we do to reduce the ingress of outdoor pollutants? So we can air pollutant emissions from sources such as vehicles and industrial processes are controlled by various legislation, regulation and guidance. However, despite such control measures being in place, outdoor air pollution levels in the UK are still relatively high and likely to be so in the foreseeable future. We're moving away, and we're getting towards electric vehicles and things like that, so it's going to be coming down, but we still need to, be working on this. Building air tightness. Once a contaminant from outdoor sources reach the building, the extent of pollution ingress will depend on the air tightness of the building envelope and the number of openings, as well as the ventilation strategy. Advantageous gaps and cracks in the building envelope contribute to the air permeability of the building. Therefore, reducing air permeability by sealing the building envelope and increasing its air tightness will actually help and reduce air ingress and so the air pollution. I've just touched on the air intake positions. There is recommended guidance, which includes the intakes need to be placed away from direct impact of short-range pollutant sources, such as roads, especially if they're within a few metres of a building. Inlets for mechanical systems can be placed on the roof to avoid ground-based pollutant sources if there's no other sources, present at high level. Quite often we'll find that we'll go on top of a building and someone will have put an intake next to a kitchen extract or a toilet extract. So there needs to be consideration when people are putting these the inlets on the roof from the air handling units. And Rob touched on the filtration. It's used to physically remove particles, and in some cases, environmental gaseous pollutants from the ventilation air supply. Virtually all mechanical ventilation systems incorporate some form of filtration, but this is usually primary just to protect the HVAC system rather than to improve the air quality. It's so that it doesn't damage the HU and it works to its full capacity and it's working to its design. It's not usually, as it says, it's not for the quality, it's more for the system. Particle filtration performance basic filters are used to remove large particles such as dust, but they offer little protection against smaller respiratory particles. They're classified as general or G filters, and in advanced ventilation systems they'll form part of a pre-filter. So reducing the indoor pollutant emissions, it sort of falls into three categories. You've got indoor air pollution source control. So historically, there has been a lack of awareness amongst occupiers and buildings that certain activities pollute the indoor environment and can cause adverse health effects. A common misconception is that dilution with fresh air is the only way of removing harmful contaminants from the occupied space. It's more effective to control the source of the pollutant if possible, especially as outdoor air may itself be contaminated coming into the building. So preventing indoor air quality problems by source control is generally less expensive than identifying and solving them after they've occurred. The generation of internal pollution can be avoided, for example, by using low emitting furnishings and carpeting and discouraging pollutant emitting activities. You then have ventilation and recirculation. Ventilation is most suited to providing fresh air for occupants' respiration and to diluting and removing unavoidable pollutants. These include those generated by occupants themselves, as well as pollutants from activities including cooking, washing, localised source pollutants such as those generated by office equipment should be extracted at source by localised or central ventilation extraction. In each case, the extract location needs to be close to the source. In mechanically ventilated commercial buildings, recirculation of part of the indoor air almost occurs. So some filtration, especially for particles, is normally required. Sometimes recirculation systems are used in the home, and sometimes they're used for allergy type problems, but we don't come across them a great deal, but they can be used in the home. And again, filtration. Indoor air can be cleaned by filtration and then recycled within the building or room. The systems can range from those that treat air in the air handling unit of the building, or you can get individual and standalone units that are located in rooms. So, pre-COVID, this is a general view on what we were doing before the lockdown in March, and it was, whilst there's all the industry standards out there, it was tailored by, I suppose, clients asking for certain things, and it started many years ago with sick building syndrome, and I think we've all heard of that. And as you can see there, it says in 1984 World Health Organization report suggests that 30% of new and remodeled buildings worldwide may be linked to symptoms of sick building syndrome. Sick building syndrome, causes are often pinned down to flaws in the heating, the ventilation, air conditioning systems, and the lack of adequate fresh air exchanges. Other causes can be outgassing, sometimes of building materials, volatile organic compounds, molds, use of chemicals, poor lighting. There's many different things to it. The indicators for sick building syndrome include, but are not limited to, symptoms such as headache, irritable eyes, nose, sore throat, coughs, dizziness, and they associate it to sick building syndrome because most of the people that complain, they report relief soon after they leave a building. So that's how sick building syndrome came around. It's not something that we get a lot of inquiries nowadays. I must admit, the ventilation is a lot better nowadays. The design is much better, and I think they've eradicated quite a lot of the sick building syndrome inquiries that were coming out. So we have a good requirement for indoor air quality. So there's a provision of sufficient fresh air supply rates to dilute and remove pollutants. So effective ventilation, providing ventilation where it's needed and in a form that most effectively removes all air pollutants. Another requirement for good IAQ is low external pollutant concentrations. It's always going to help. And low pollutant emission rates from internal sources, including materials. I think good IAQ may be defined as air with no known contaminants at harmful concentrations. Common contaminants or pollutants, including gaseous pollutants such as carbon dioxide produced by occupants and combustion appliances, volatile organic compounds released by carpet glues and other materials, odours and particles. In an office environment, the fresh air ventilation rate is 10 litres a second per person. Therefore, the total fresh air flow rate for rooms given by the flow rate per person multiplied by the number of occupants. I think it's quite an important thing that the flow rates need to be right in a room, and I'll come on to that in a short while, to ensure that you've got that good quality of air there. The HSE says that, I think Rob touched on, so temperatures in the indoor workplace are covered by the Workplace Health and Safety Regulations 1992, which place a legal obligation on employers to provide a reasonable temperature in the workplace. The approved code of practice ACOP suggests that the minimum temperature in a workplace should be at least 16 degrees Celsius. And if the work involves rigorous physical effort, the temperature should be at least 13 degrees Celsius. They can't give a figure to the upper end of the scale due to the high temperatures found, for example, in glassworks or foundries. In those environments, it's still possible to work safely, provided appropriate controls are present. And then risk assessment. The Management of Health and Safety at Work Regulations 1999 require employers to make a suitable assessment of the risk to the health and safety of their employers and take action where necessary and where reasonably practical. I've put some air exchange rates on the right hand side on the slide there. If you go on the internet, you'll find all different exchange air rates, and people recommend different rates, but they're all about the same, and you'll find a happy medium there. But it's an extensive list if you have a look on the internet and look at some of the HSE documents. So general, some of the factors for consideration: high, low, and excessive fluctuating temperatures in a workspace can be very uncomfortable for building occupants and may exacerbate existing health conditions. There's also a gender divide. When we were back in the office, I sat in an office where there was probably 50% men, 50% women, and the men are always warmer, and so they prefer it cooler, and the women are always, they want it nice and hot. A person's body mass, their metabolism rate, that's also likely to have an impact on the individual's perception of what is a comfortable room temperature. Drafts, airflow from ventilation grills, people sitting under the aircon units, air conditioning units, they always have, they always say it's freezing cold, and they can also cause stiff necks and dry eyes. So it's something to take in consideration. So the monitoring and ventilation systems, typically in pre-COVID, a client would contact or invite us to undertake a survey of a ventilation system, and it would usually be after they've had a complaint from a member of staff about a dirty grill, an engineer changing filters and he's observed dirty ductwork, or maybe the AHU had broken down and an attending engineer had commented on the condition. However, the survey would only be to get an understanding of how dirty a system might be. They were never really looking at the air quality. We might have been asked to take a survey of a section of a system or a whole system, from the intake to the point of discharge located in an office, a classroom, or a restaurant, for example. This would typically include surveying the air handling units, the pre-filters, the coils, the bag filters, the filter, and the fan system, everything associated with that ductwork system. And then during that survey, they might request us to take a deposit thickness tests, which is Rob touched on, is an improved technique. I find that it's a really reliable and quantitative way of measuring the degree of cleanliness in ductwork, and it would determine when and how frequently cleaning is likely to be required. It may also be that the system had never been cleaned, in which case the type of testing we wouldn't even need to undertake, because the level of contamination from a visual point of view would have been so high that the industry standards of cleanliness of ductwork, albeit supply, recirc, or even extract, would have visually failed. As Rob touched on, we'd use an alcometer, which you can self-calibrate, and that would take 15 measurements from an area about 15 centimetres square, and it just sends a signal down to the ductwork, and it just measures in microns the depth of the dust, and then you relate it back to the table that Rob showed earlier for depending on whether it's a supply, recirc, or an extract system. Alternatively, there is the preferred vacuum test, and you can find information on this on the internet or in TR19 or on BSEN 1570, which Robert referred to earlier. This test consists of an air pump with high volume drawing 15 litres of air a minute, and it draws it in through a cassette, and it's a pre-weighted cassette. The air pump's calibrated to within plus or minus 5% of 15 litres of air a minute, and a template typically about 10 metres squared. It could be different shapes depending on if you've got an awkward position to get into. As long as you can use that sort of area, it'll be attached to the ductwork. You then fit the cassette onto the tube from the pump, and then you have another piece about 5 centimetres in length, the other side of the cassette, and you physically hoover the ductwork, and it draws it up into the cassette. And you don't draw the pipe work across the ductwork any faster than about 5 centimetres a second. And then once you've completely vacuumed it, you can take the pipes off either side of the cassette. Then you put the plugs back in, and they get sent away for a site analysis and weighed. And then the weight of the dust in the table that Robert showed earlier will tell you whether you need to get your ductwork cleaned or not. I have a personal preference to the deposit thickness testing, because for me it's very black and white. You just put it on the ductwork and it will tell you how thick the dust is. With the preferred vacuum system, I have a slight concern that an engineer might go along to site and he might put the tube on the ductwork, and he's not going to give it a very vigorous hoover. And he's going to go, because he's been doing, let's say he's been doing it all day for 8 hours, and he's going to just think, oh, I've got to get home for my tea at 5, so I'm going to spend 5 minutes doing this. So he'll give it a little scrape over. He might hold the tube at a different angle and not have it flat on the dirt to pick it all up. So for me, I just prefer the deposit thickness testing. The preferred vacuum test, it's recognised, but for me it's a little bit flawed, I must admit. But I can understand why people use it. We've also been asked to monitor carbon dioxide levels in the past. We all produce our fair share of CO2, and we breathe out almost a kilogram of CO2 on a daily basis. When you put a lot of people in a large number of people in a workplace, that can rise significantly. And it is typically the most relevant test parameter with regards to indoor air quality. If you know the size of the room, and you know roughly the average that a person gives off, and what your ventilation system is working at, you can roughly work out how many people should be in that room. However, with the CO2 levels, you might be asked to go in and do it in a room where there's no one in at that time. So, and it can change. You could have 10 people in the room one day, and you could have 20 people in the room the next day. So all you can do is you can give your opinion of what it should be. And carbon monoxide. So we're asked to monitor that as well, just in case there's gas heaters that are broken or boiler flues. But and then there's microbiological sampling, where they test for bacteria and fungi. Again, it's in the air. Going back to the HTM. The guy that writes that for the NHS, he again aired his concerns to me and said, well, it makes no difference. Why are you sampling the air for that? You could have, I think his exact words were, you could have the worst asthma in the world and you're not going to catch anything from the readings you're getting on those agar plates. So it's quite an interesting one. People do ask us to take air sampling, and they do ask us to take samples using the plates on AHUs, and often ask us to clean them out. But for us, it's a bit of a grey area. I can understand why people do it, but the NHS, as I said, who are unbiased, say no, don't do it. But I can understand why people do it. The air sampling, though, so if you do use it, there's a piece of equipment on the slide there, and you just put a blank plate in the top of it. and then you take samples from at least 2 rooms served by the air handling unit, and try and put one near the start of the AHU, the system, and one at the furthest. So you're getting a range of what that's going to be at either end. So you know, if you've got a high reading at the start and a high reading at the end, you know it's going to be the same way through. But if it's high and low at the other, you can then try and work it out. Doors to offices and the openings to outdoors should be kept closed during the sampling. Ideally, the office should be vacant at the time of the sampling. If that's not possible, you should stay at least 2 meters away when that sampler's running, except when taking maybe ceiling level samples. A first set of samples should be taken in the centre of the room with the sampler at least 100 centimetres above floor level and facing the ceiling. Ideally 50 centimetres away from soft furnishings and tables or anything that could put an influence on that pump drawing the air in. And then a second set of samples should be taken close to the ceiling, but not in direct airstream from a grill or diffuser. The sampler should be at arm's length. And that's generally what people asked us to do before COVID came out, and that's slowly changed to now post COVID. So there's no evidence of human infection from SARS being caused by infectious aerosols distributed through supply ventilation systems. There has been investigation reports have shown that COVID-19 transmissions can be, particularly effective in crowded, confined indoor spaces, such as offices, factories, churches, schools. But however, as it says, there is no evidence at the moment that it can be caused by a ventilation system. Based on this, we should ensure that every building, office, school and classroom system, though, undertakes a specific risk assessment to ensure that whilst there's no evidence, we are in fact getting the best possible air quality into these areas. I think it's only right that we're proactive. It's not been proven, but I think it's proactive that we need to do something to make sure that we are getting the best possible air in there. We need the correct airflow rates going into these rooms. Large spaces such as classrooms, they're well ventilated, but they can easily become overcrowded. Small rooms occupied by a couple of people, they show the highest probability of infection, even if they're ventilated. You may have internal rooms that don't have any ventilation to them other than the ventilation systems located in the outside corridors, maybe. And I think ventilation to these spaces, they need to be investigated and addressed in the current climate for the best future practice. The general recommendation is to stay away from crowded and poorly ventilated spaces. In buildings without mechanical ventilation systems, it's recommended to actively use openable windows. You should be using much more than normal. A window is a fantastic way of boosting your air exchange rates, and let's face it, it's free. It's free to open your window and get some nice fresh air in there. People have been recommending open a window 15 minutes before you go into a room and shut it 15 minutes after you leave. I think it's fair to say that if you've got an engineer who's based on site, you've got an FM company, if you've got a caretaker, then see if they can open a window for an hour. Let's try and dilute that. It gets some nice fresh air in there. That can only help the whole situation. It's just an easy and cheap way of getting fresh air into your building. It's also been recommended that central recirculation systems not be used during the current pandemic, but there are several solutions out there that enable these still to be used, based on that there's no evidence that you can catch COVID from the ventilation systems. You can close the recirculation valve on the system, prevent it being recirculated, but you need to be aware that they have a leak percentage, and this leak percentage is recognised at installation stage. That you can have up to 3% leak percentage. So even though you shut that valve, it will still be going. It will still have a bit coming out. You can also regulate the pressure on an AHU, the supply and the extract, so that if it's a recirc and you can balance it so that the air actually gets taken back out of the extract. It will cross over, but come back out. So, but sorry everyone, I have reminders because I forget to take my tablets. Let me just turn this down. Yeah, on Reaver, there's information about this that you can find about balancing your air handling units. But alternatively, you can also fit a purge sector into your air handling units. And the purge sector is a mechanical device that projects a jet of air through the rotor on an air handling unit from the clean airstream to the dirty airstream. What it does, it tries to blow as many of those particles off and then into the rotor, so then it throws them back out of the HU and out to discharge. So there are things out there. The Reaver website is a really good website to look at for that, and you can actually set up your air handling unit to do that. So while there are many possibilities to improve the ventilation solutions, I think it's important to recognise that there is current technology and knowledge that already allows the use of many rooms in buildings during COVID. You know, we can still use these rooms as long as a risk assessment is conducted. We can use them. Check that we've got the right air exchange rates. That's a massive one for me. If you've got the right, as long as you're giving the good advice and everything's working well, and you've worked out the air exchange, carry out that risk assessment. I think that's the first one. You can use Hepa filters. However, due to you put a Hepa filter in, there'll be a high pressure drop, and you'll need potential modifications, and it's not always an option to fit Hepa filters onto an existing system. Alternatively, you can install disinfectant device into an air handling unit. You can put an ultraviolet germicidal irradiation device in there, and that will kill it off. But it's essential that that's correctly sized and installed. If technically possible, it's preferred to mount a high-class filter in the existing frames and to increase the exhaust fan pressure without reducing the airflow rate. On the right, you can also see that the top picture is a UV system that can be installed actually in office areas. It's a little UVC system, and it's typically, I think it's they're about 25 centimeters, 30 centimeters in length. They mount from the ceiling. They can be wired into the system in that room. They just need a power source, and they draw the air in at head height. The UVC, whilst it's not good for us, it's contained in that unit, and as it draws it through, it will actually kill off COVID-19 and just put that fresh air supply straight back into the room. And alternatively, you've got the remote carbon dioxide monitoring, and the system there. These systems are fantastic. There's more of these coming on to the market. I was reading about one yesterday that has one sender unit, and you can tie 100 of these monitors into it, so you can have a whole building literally wired up. So if you've done your risk assessment and you've got the right amount of people in the rooms, this will just monitor it and make sure it's okay for you. You've done the risk assessment, and these are a great bit of kit that you can put in. They're wireless, they run on long-lasting batteries, they can link into your BMS systems. You can then have a dashboard on your phone, your tablet, your PC, and they give you instant access to, there's up to 6 or 7 different types of readings they're taken. As you can see, I just put carbon dioxide, humidity and temperature. It's just 3 of them, but I think it's 7 or 8 different things that they pick up. It then has warning signals that can warn the engine or the engineer or the building occupant to open windows or adjust the mechanical ventilation. And you can also store the data and provide the facility managers with a weekly or monthly data report, just so they know what's going on in their buildings, and they know where the high concentrations are, and they can then and they can try and help identify the infection risks caused by a high buildup of carbon dioxide. To finish, I think it's fair to say that there are many possibilities to improve ventilation in the future, and it's important to recognise that there is already the technology and the knowledge which allows the use of the many rooms in a building during COVID-19 type of outbreak. you know, if the ventilation meets the existing standards and a risk assessment is conducted to ensure the correct ventilation is being provided to these areas. I honestly believe that as long as we're doing these risk assessments properly and it's monitored, I think we can get back into buildings, and that's the way that we need to be looking at driving the IAQ monitoring. And there we go. Thank you very much.